this is
Because
before you
he
get
never
to class.
even had a job, even though he said he does.
Okay,
Not
dude.
that hard.
Slope intercept form, we're going to use that. Right at the very end of class today, we're going to learn how to write these equations for perpendicular bisectors. Actually, write the equation for a line on a graph.
This chapter 6.
Yep. Just write down that title. I'm getting ready to switch the slide. And that's probably the hardest thing that we're going to do today is writing those equations, because it's got a process. You got to do 6 steps. You have to be able to do those steps one by one. Daniel knows that when he starts doing steps and it's got 6 steps in it, he probably gets to number 1, then he does number 2, and then what happens?
What's the name of the one?
That's too long. Huh?
What's the name of the
Slope
one?
intercept form. It's too long, right, Daniel? I need to sort of. I got 4 more steps. I don't feel like doing this. Does that ever happen?
Yeah.
All right. Write this down. Again, don't lose these passes. Hang on to them. At the end of the year, if you have them, turn them in, they'll be bonus.
Can we still use them like this order?
Yeah. That'll be all right, as long as they haven't been used. Nothing else, sell them to Quentin, he'll use all his.
Yeah, just like
Bro, I'll do that.
He'll use all his this week. So, next time he wants to go somewhere, somebody say, $2.
I got you.
Mine are worth $1,000.
Mark their piece of paper.
Mark, if you handed too much,
Yeah. It's gotta be sellable, Mark. That means you're never gonna have your own company if you're gonna charge that much for something like this.
Unless we have Bill Gates in here. Unless you really gotta go to the bathroom.
Somebody's always gonna come in and undercut you on your price.
I'll sell it for a freaking penny. I wouldn't pay to go to the bathroom.
Wait till that day,
Pee on your
you see
floor.
Quentin's got like a candy bar or something, and you say, Quentin, I'll give you one of my passes for that candy bar.
But think about it this way, like, what if you really have to go, like, to the bathroom and you just, like, pee yourself, then you'd be humiliated. So you actually.
Well, they're the ones that are gonna have to clean it up, 'cause they're the one that charged you. So, that's their fault.
Alright, equidistance. Equidistance, all equidistance means is the same distance. So if I put no, stupid. This pen. I got a house here and I got a house here. Then I got some other house down here. This is John's house. This is Fred's house. And this is Sally's house. And I say John's house is equidistance from, or John and Fred's houses are equidistance from Sally's house. What's that telling you about those 2 segments right there? They're equal, they're the same. That's all equidistance means. Don't make it harder than it is. It means they're the same distance. Now what we'll do a lot of, if we look at this picture right here, I know that point C is equidistance from what other 2 points in this picture?
A and B.
A and B. And these tick marks tell us that. C is the same distance from A as it is from B. And we know that C is what kind of point? What's it called? Midpoint. Alright? It's the midpoint. Getting this right here. Sort of difficult. I don't really think it's difficult, but a lot of students do. Perpendicular bisector. Exactly what the name sounds like. It's perpendicular. What's perpendicular tell us? Right angles. So anytime you hear perpendicular, right angle. What's bisector tell us?
It has to bisect.
Bisects it. In this case, it means it's splitting it into congruent segments. This line right here, ED, is the perpendicular bisector of segment AB. How do I know that the line's the perpendicular bisector and not the segment? Because what can you not do to a line?
Lines cannot be.
They can't be cut in half. They can't be bisected. So this has to be the perpendicular bisector, and this is what is being bisected and what is being or is perpendicular to it. All right? To be a perpendicular bisector, if this is our perpendicular bisector, it's telling us that that's a right angle. What do we know about this angle right here? It's a right angle. How about this one? Right angle. How about this one? Right angle. And so that's the perpendicular part. Now the bisecting part tells us that these two segments from here to here and there to there have to be the same. They have to be congruent to each other. Perpendicular bisector. Very easy. Don't make it harder than it is. You just got to be able to pick it out in the picture. All right, on this, what I want you to write down. Write that, then that sentence. Write that, then that sentence. You may want to draw the pictures over here also. That's totally up to you. Right? Do whatever you're sure is going to help you.
Those are exams. Are those exams or not? What? I don't know.
No, those are our quizzes.
Yeah, I just realized that.
Have you done grading?
Yeah, there's a grade book. Yeah.
Quentin wasn't listening when somebody else asked earlier when you were going to see your exams. Sorry about Teresa. Never.
Actually, we're going to see them on our.
Just see the grade, Mark.
You won't see the actual
You
test.
see the smoke from his house. From my chimney.
Never see the exam. Too much headache. 'Cause then I gotta explain to Trina why, when I said name an angle, and she wrote that down, I gotta explain to her why I marked it wrong. You don't wanna have all that headache. Might have to take Lane's other pass, he's taking too long.
Oh, he's gone still?
Yeah.
Oh my gosh, look, it's been like that now.
Probably dropping loose.
You used up 2 passes, didn't he?
Yeah.
If he's not back here in the next minute, then I will.
No, really? I dare you.
I would.
I heard you wouldn't.
You wrote wrong. 203 rolls around. Trash can it goes.
Just do that. I want to see his reaction.
Wait for him to come in here and tell him first. And then.
No, as soon as he walks in, act like you don't see me, just be like, alright, well, he's used both his passes.
Alright, on this, in a plane, if a point lies on the perpendicular bisector of segment, then it is equidistant from the endpoints of the segment. Who we got right here?
What?
I was getting ready to take your other pass because you were going too long.
How long did I have till you took the other pass?
A minute.
About
You
30
better
more
have
seconds. 203, when the clock turned to 203, you were done.
You're about to be done.
So what they're saying here, if this is the perpendicular bisector, and this is key for all this is where everybody gets confused. And I put some point right here, and we call it point E, because that's Ebersol's point. I know that that point is the same distance from the endpoints of the segment, or it's equidistant from the 2 endpoints. What are the 2 endpoints of the segment? A and B. So when I connect A to E like that, and I connect B to E here, what do I know about those 2 segments that I just drew? They have to be the same length. Right? Michael comes up, and he puts a point right here. And he calls it point M, because that's Michael's point. What's he know about the distance from his point to A and his point to B? It has to be the same. That distance there is the same. I was going to say Mark, but I can't. Trina comes up. She puts a point right here. That's point T. What does she know about point T? Same distance from A as it is from B. No matter what, lay it on the table.
Yep.
It's got to be the same distance on both of them. All right?
The one that's empty.
Now, when you're looking at this, if I have this segment and I have a perpendicular bisector, and I put some point up here, and we know that those two are congruent, we know that that's a right angle. If I draw in these two segments, I know that those two segments are the same length. Well, what did I just form? Two triangles, right? Actually, three triangles. Two small triangles and the big triangle. I know that those two sides are the same. What did we just say about these two sides? They're the same. What do I know about this segment and the triangle on the right and this segment and the triangle on the left?
They're the same.
It's the exact same thing by the reflexive property. What can you tell me about those two triangles then? They're congruent to each other. So anytime you have a perpendicular bisector of a segment, if that line right there is a perpendicular bisector of that segment, and you pick some point out here on that perpendicular bisector, and you connect it to the two endpoints, what can you tell me about those two triangles? They're always congruent to each other. And if those two triangles are congruent, what can you tell me about this angle right here and that angle?
They're the same.
They're the same because of CPCTC. All right, so this all leads right, or comes straight from what we were doing before. If the second theorem here, it's the converse. What's it mean to be the converse? What's the converse do? Switches the hypothesis and the conclusion, so it just turns it around. It says, if you have this segment's congruent to that segment, this segment's congruent to that segment. If we connect those 2 points, point P and point D, that line right there has to be the perpendicular bisector of that original segment. So it just sort of turns it around. So instead of knowing you had a perpendicular bisector, it's saying these A and B are equidistant from P, D is equidistant from A and B, then those 2 points have to make up the perpendicular bisector. I'm so proud of you. Thank you. I don't see any doodles or anything. You're on at this 9 weeks, aren't you? Did you figure out over break? My God, I can't handle another year of every soul.
Oh, what's that word right there? That it is what?
Where?
No, just it says to be watching
That it is
foibles.
Equidistant.
Foible.
Lane, tell me at the end, we'll come back. Looking at this, if line GB is the perpendicular bisector, you'll never see me write out the words perpendicular bisector. As a matter of fact, that's more writing out than I'll probably do because I'll write it that way every single time. All right? Too much to write out. Line GB is the perpendicular bisector of OT. Michael's going to come up here and he's going to mark a bunch of stuff because he wants to sit there and talk to Tyler and think that I don't know what's going on.
Tyler, I'm not talking to Tyler.
Yeah, he's talking to Daniel.
No, I was not.
He's talking to
That's
Whoever.
Oi.
So, if it's the perpendicular bisector, what do we know? Tell me, let's mark some things in that picture that we know. Hear what she said?
I didn't hear it.
You might have to tell him what it is. ON what?
Like the segment of it.
Segment ON.
And then segment
Does everybody agree with that? Those two segments have to be congruent.
And start.
What else do we know?
Right angles.
What's a right angle?
G and T. T.
Stop, stop. Angle GNT is a right angle. So what's he going to put in there? Got to hold it perpendicular to the board. What other angles does he know is a right angle? Michael just likes being up front, doesn't he? Because could he have had all those right angles marked by now?
Yeah.
Just make a giant square.
He knows all 4 of those angles are right angles.
This is fun.
Now Michael's going to pick a point on the perpendicular bisector. It's not going to be fun now because now he's going to be lost. So he's going to make a point on the perpendicular bisector.
Make a point.
Yep. You make up your own point on the perpendicular bisector.
That not
That's the bisector. GB's the bisector.
He started to put it in the wrong spot.
That's not.
So that's his point. What can Michael tell me about his point? Besides that,
It's the same one. Not very good at it.
same distance from what?
Point T.
Point
Point
O.
O and point T. So the distance, thank you. The distance from here to there is the same as the distance from here to there. It's got to be the same. Teresa comes up, she puts a point right here. What's she know about it? Same distance from O as it is from T. Quentin comes up, he puts a point right there. What's he know about it? Same distance from O as it is from T. Is GB the perpendicular bisector of OT? Looking at it.
Yes.
Is it the perpendicular bisector? How can you tell if it is or not?
It's making a 90-degree angle. Right?
Makes a right angle, so that's part of it. Does that mean it's perpendicular bisector?
14.
Yes, that means it's perpendicular bisector.
No, it means it's perpendicular. If these are both 14, that means they're congruent, so is that segment being bisected? Yeah, so is it perpendicular bisector? Yeah. Any point on what? Line GB is what from O and T? Equidistance. Equidistance. It's the same distance from these two endpoints. So if I pick some point right here, same distance from here to there as it is from here to there. What do I know about these two triangles? They're congruent. What can you tell me about these two angles right here then? They're congruent to each other. So those two angles are congruent. What does ray NG do to this big angle right here? It bisects, splits it into two congruent angles. Real quickly, find segment SR. Remember, this means find the length of segment SR. How long is segment SR? 6.8. It's that simple. S has to be the same distance from R as it is from P because segment or line SQ is the perpendicular bisector. Find the length of segment EG. How would we do that? What do we know about segment EF right here? Congruent to FG, so it's 9.5. Well, we wanted EG, so what would we do there? Add them together, it's 19. How could we find segment CD? That's this segment. What would you do with these two? We know that they have to be congruent to each other because point D is on the perpendicular bisector, so it's the same distance from C as it is from A. And then we set up this equation. 3x plus 14 should equal 5x. We solve that, you end up with 2x equals 14. What's x equal? 7. Is that our answer? No, we want CD. How would we find CD?
Plug it in.
Plug it in. 3. And we work 3 times 7 plus 14. What's 3 plus times 7? 21 plus that? 35. How long is segment AD? 35. Gotta be the same. Is ZX a perpendicular bisector?
Yes.
Why not? Yes?
Yeah.
It has a 90-degree angle. It makes a 90-degree angle.
It's got a 90-degree angle right there, so does that make it a perpendicular bisector?
Yes. It has to.
I mean,
it could be WY.
It does, the perpendicular part.
But it's not bisect.
It doesn't bisect,
Okay,
does
so
it?
it's gonna go all the
So,
way through.
so what two segments would we need to know are congruent to say it's a perpendicular bisector?
WX.
Segment WX and segment XY. You gotta be careful, don't just look at it and say, yeah, it looks like the same as the other problem, so it looks like a perpendicular bisector. You gotta have the information. All right, go ahead and write this down, angle bisector.
Did I turn it in the right place, right? Had my name on it, right?
Had Fred's name.
Okay.
There used to be a TV show.
What?
Used to be a TV show.
Fred's name on it.
Fred. Remember the TV show Fred?
It's like that.
Yeah,
There's one show.
God, I hate it. I like
Oh my
it.
god, I hate, now you remind me. Thanks a lot.
He hated it, but no, he watched it all the time.
No, I did not.
Dude, his
I
dad
watched
is John
it. I
Cena.
watched it
Like, that was
Me and
the
Mackenzie
best.
would watch it all the time.
I wonder how guilty John Cena is for putting himself on that show.
No,
He's
Surprised
a
he hasn't
he
refrigerator.
loved it.
Killed himself yet from that.
I'm surprised he hasn't killed himself from all the memes of him.
Yeah.
One with his head.
Surprised he just hasn't used the high frequency of his own voice to pop his own head.
So an angle bisector. What's an angle bisector again?
Right, that splits into an angle. Splits an angle into two congruent angles.
Tell me the two congruent angles in this picture.
TN and
Ah, I don't think so.
Angle
TH.
NTH.
Angle NTH. What's Lane got to remember? How many letters to name an angle?
3.
3.
It's like that.
So angle NTH. That's this angle right here. What's it congruent to?
HTS.
Angle
Yeah.
HTS. Gotta make sure you know how to name angles. Again, get rid of that. It's wrong. From here on out, for the rest of the year, you don't put your symbols, it's wrong. It's wrong anyhow? Oh, you don't have to match them. That's just for the triangles, you gotta match them up. Angles, it doesn't matter because that angle and that angle, no matter what, they're gonna match up. Because the sides don't have certain lengths. So that's an angle bisector. Now with an angle bisector, what we're going to learn in these next two theorems, if I put a point right here, and we did stuff like this earlier this year, I think we used Michael and said Michael was out in the desert and he was going to die of thirst if he didn't get back to the road.
And we drink back in here.
So let's say the roads, these are two roads, and we want Michael to go to one of those roads as quickly as possible. Do I want to send him like over there? No. All right, maybe I do want to send him over there, but should I send him over there? I
Yes.
said it wrong.
Do what the heart tells
We want to go right here, and what's it got to form?
you. Right.
A right angle. And what we know, any point that falls on this angle bisector, sort of like the perpendicular bisector, is the same distance from this side of the angle as it is from the other side of the angle. But they both have to have those right angle symbols in there because it's got to be the shortest distance. Okay? So if I have some angle here and it's being bisected, and I have some point right here, I draw that, and I draw that, what do I know about that segment and that segment? They should be the same. Even though my picture doesn't look like it, they should be the same. So any point that falls on that angle bisector is equidistant from the two sides of the angle, just like with the perpendicular bisector. And that's what these next two theorems are going to say. On these two theorems, write that, oops, write that and that, write this. Again, you may want to draw the pictures, that's up to you, whatever's going to help you the most. Again, the second one is the converse, so it just sort of turns it around. The first one says, if a point is on the angle bisector, then it's equidistant from the two sides. The second one says, if some point is equidistant from the two sides, then it must be on the angle bisector. Turns it around. Go away, Lane.
told me not to get the cards unless it's a lemon. Always get the lemon.
Michael, hold on. Mom's prank on me. Hey, you see that card that's going by? Go get it.
Oh wait, that looks pretty.
Accidentally hotwired
We
and
never
accidentally
take
steal
candy
it.
unless they have a white van.
Yeah, if the van says free Wi-Fi, get
You
in.
accidentally
99%
go
of
out
the
and
time.
buy it.
Wi-Fi's on spot. I'll buy your van. It's not
You go up.
So on this first one, if we pick some point at random that falls on that angle bisector, and we know it's an angle bisector because those two angles are congruent, pick some point on there, it's got to be the same distance from those two sides. So those two lengths right there have to be the same. We pick some other point that's right here, got to be the same distance. Some other point that's right here, it's the same distance from the two sides. The second one says if we have some point, point D, and we know point D is the same distance from that side of the angle as it is from that side, then from A to D has to make the angle bisector of that angle. So what would we know about these two angles right here? They got to be the same. Again, just the converse. A lot of people forgetting when you write an if and then statement, what's got to be the first word? If. What's got to come in the second part of the sentence? Then. And when it does, all it does is it takes this hypothesis and the conclusion and it switches them around. It takes the hypothesis and the conclusion and switches them.
I can just take a case too. I'm not finished. Mr. Epperson, what'd you do over break? Just great stuff.
Hidden from you. You didn't find me, did you?
Well, I didn't exactly break the search party. I didn't exactly break the SS with it.
Good.
You're gonna bring out seal tape.
Hey, you would have found me during break except for the last couple of days because I wasn't even here.
Yeah, you're in your closet making this.
So any point on ray AD,
I'm being comfortable.
any point on ray AD is the same distance from the two sides. But you gotta remember those distances have to be given with the right angle symbols, with the perpendicular symbols there. So if I'm looking at this, is this an angle bisector? Yeah. So what do I know about these two segments right here? Same. So what equation could I set up? Now I set it up backwards from what Teresa says. Does it matter if it's backwards? Move that over, you get negative 1x equals negative 5. Divide both sides by negative 1. What's x equal? 5. But they wanted to find the length of segment PS. So what would I have to do? Plug it in and get 25. What can you tell me in this picture? Is this the angle bisector?
Yeah.
No,
Yeah.
no,
Yes.
no.
Yes.
Maybe.
Yes, because it's equidistant from G and H.
So if we look here, this distance, which is on this ray, is the same as this distance. So is that the angle bisector? So what do we know about these two angles? They're congruent. So if this is 42, what's this one? 42. Now they ask us to find angle GFH. How much is angle GFH?
Add it.
You gotta add them together and you get 84 degrees.
Boom, Teresa.
Is that a perpendicular bisector?
No.
Yes.
Doesn't have midpoint.
But
Yeah,
yes.
just kidding.
So what's X?
What would you do?
5? Is this a perpendicular bisector?
Yes. Yes.
No.
No, but is it an angle bisector?
Yes.
So what do we know about these two? They gotta be the same. So what would X have to be?
8.
8?
Oh, 8, yeah, you're right. The entire thing's 50.
Is this a perpendicular bisector? an angle bisector, so what do we know about these two? They're the same. If we set up an equation there, 2x plus 1 equals 5, what would x equal? 2. Angle bisector or perpendicular bisector? Or neither? Angle bisector.
Angle bisector.
So what do we know about those two? It's got to be the same. I'm not solving that one. Write this down. This is the hard part when we got like 6 minutes, so you got to write quickly. Six steps to writing an equation of a perpendicular bisector. Number 1, graph the original segment. They're going to give you 2 points and they're going to say this is a segment and you want to graph it. Number 2, none of this should be hard because we've done all this earlier this year. Number 2, find the midpoint. What formula did I have written down there for you? I'm going to throw something to you. Midpoint formula. That's why we're looking for the midpoint. We use the midpoint formula.
Come on, Teresa.
Number 3, find the slope of the original segment. If we just graphed it, how can we find the slope?
Rise over run.
Just count. Rise over run. Number 4, we did this earlier this year. If 2 segments are perpendicular, what do you know about their slopes? They are, look in the red up there, opposite reciprocals. So you can find the slope of that of the perpendicular bisector because it's got to be the opposite reciprocal. We did that with other things. Number 5, use the midpoint, the coordinates you found for the midpoint, the slope that you just found for the perpendicular bisector, and y equals mx plus b. What form is y equals mx plus b again? Slope intercept. Use those so that you can find b. Once you find b, then you're just going to take that y equals mx plus b and you're going to plug in the b and the m, and that'll be your equation. Yes? Yes? Sure. No, thank you. Bye-bye. Cole, why would they come get you 4 minutes early?
He's special.
We already knew that.
Supposed to leave like 15 minutes early. I have an appointment.
Probably.
What's for?
I think you're gonna be a little late.
Why would they done?
Have fun with that.
Hope you can handle all that on your own then.
What is it?
Don't bite his fingers. I'm always gonna bite his
What kind of dental work are we getting done?
I'll be getting my retainer for got some braces out there.
Right quickly, because I'm getting ready to change it. 4, 3,
2, 1, 0.
2.
We started soon.
Hang on.
Or,
Teachers, pardon the interruption for a few afternoon announcements. Good luck tonight to the varsity girls basketball team as they travel to Richmond at 7 o'clock. Bus leaves at 5:45. And good luck to the varsity wrestling team that is home versus Union City and Twin Valley South. That starts at 5:30. In addition, all wrestlers need to report to Mr. Eiler's room after school. Masks need to be rolled out right away. That's it for your first day back Tuesday. Have a great afternoon, make it a great day, or not. The choice, of course, is always yours. Have a great Blazer Tuesday.
I'm so glad he didn't do the Scream Blazer thing.
He should have.
No.
I'm glad he
That's
does
so
that.
freaking annoying. Every
So
morning I'm just
freaking
like,
annoying.
I'm just like, everyone shut up.
You and everyone in my freaking English class
So,
goes in the
what's
hallway
the
and yells
homework?
too early in the morning. Anyways, homework.
Dakota, did you get it?
Maybe we should do it at the end of the day.
Yeah.
Oh, I think the homework's on Moodle.
We should do more.
That's your assignment. I was going to do that problem for you. You might want to make sure, look in the book, and they do an example for you of that last thing. But since we don't have time, or you could watch the video on Moodle, and it has the example worked out how to write that equation. But I guarantee something that'd be nice to have in your notes because I'm going to put a couple of them on the next test.
Really? Oh my god.
So you got to be able to do those.
It's
Get
always a
bored
good
towards the
day.
end,
Yeah,
Mackenzie.
those are good.
Get bored towards the end.
Okay,
We're gonna
that
have
was
to
in
email
black
them.
ink, and this is blue ink, so. She just called you out. Yeah, I just called you out.
Christ, switch.
Yeah, she said that
What I do?
I'm Just kidding with you, Mackenzie. Keep it up, though, all right?
Alright.
Just remember that how annoying I am
You just really want to have class.
and don't want to be with
Just
me.
remember that you called yourself that.
After
and
at the
not
bus.
I know I'm annoying.
After at the bus.
You-
Got in a hurry.
I think I said that all year long, haven't I?
You're a good
No,
annoying.
just a little bit.
Haven't I told you that all year
I
long?
don't annoying people.
I don't recall.
I like your backpack.
All right, on this example of how to write an equation for a perpendicular bisector of a segment. First thing you're going to do, we're just going to go through those steps. So the first thing we're going to do, I'm going to draw my x-axis, draw the y-axis. Mine's crooked, but just whatever. And then we're going to graph this point. The point -2, 3, that's P. So -2, 3, that's point P. And 4, 1, 1, 2, 3, 4, 1, that's Q. That's our segment. Now we want to figure out where the perpendicular bisector of that segment is. So we want some line that cuts through it and is perpendicular to it and bisects it. Well, the way we're going to do that, we did our first step, that was the graph. Our second step said to find the midpoint. So we're going to find the midpoint of this segment. The way we find the midpoint is use that midpoint formula. And on the midpoint formula, all you do is add the x's, divide by 2, add the y's. So the x's and the y's of those 2 points, P and Q. Add the y's and divide by 2. So the midpoint, -2 plus 4 is 2. 2 divided by 2 is 1. 3 plus 1 is 4. 4 divided by 2 is 2. That's the midpoint. So the point 1, 2, 1, 2, which would be right about there, is the midpoint of that segment. Now the reason we need the midpoint is so that we know the segment's being bisected, and we know that the perpendicular bisector is going to run through that point somewhere through there and form a right angle. Well, to form a right angle, that's what the next part's going to be. So step 3 said find the slope of the original segment. So we're going to find the slope of segment PQ. Well, if I start here at P, I go down 2. Remember, slope is rise over run. So I just said I go down 2, so that's going to be a -2. And then we count our run, 1, 2, 3, 4, oops, I'm down too far. 1, 2, 3, 4, 5, 6. So we go to the right 6. And that reduces to -1/3. Step 4, that's the slope of the original line. We want the slope of this blue line that goes through here that's perpendicular to that original segment. So what we want is the opposite reciprocal. Well, the opposite reciprocal of this -1/3, we flip it over and we change the sign. So we flip it over and we get 3 over 1. It was a negative, so now we're going to make it a positive. So the slope of our new line is just 3 over 1, or just 3. 3 over 1 is the same as 3. Step 5. Step 5, what we do is we figure out what B is. We figure out where this blue line would cross the y-axis. The way we do that is by using y equals mx plus b. And we're going to plug in, we're going to use what we found up here. We're going to use this midpoint, and we're going to use this slope, and we're going to plug those 3 numbers in here, here, and here, and leave b as a variable, and we can solve for b. In place of y, we put in the y coordinate from the midpoint, which is 2. In place of m, we stick in the slope, which is 3. And in place of x, we stick in this x coordinate of the midpoint, which was 1. And then we just solve. 3 times 1 is 3. So we got 3 plus b on that side equals 2. To get b by itself, you subtract 3 on both sides, and you end up with b equals a -1. So we now know what the y-intercept of this blue line is, and we know what the slope of that blue line is. So our sixth step is just to write the equation in y equals mx plus b form. And all we're going to do this time is we're going to replace the m and we're going to replace the b. The y and the x stay as variables. So we end up with y equals, let me erase that, y equals, our m was 3, our slope was 3, x, our b was -1, so -1. That's the equation of that blue line right there. Y equals 3x minus 1. And it's important to know this perpendicular bisector, because if you have a segment and you want to split it in half, so you want to bisect it and you want to form a right angle, we could use that. And we could also use it because if we find a point on here somewhere, like that point right there maybe, we know that that point's got to be the same distance from P as it is from Q. And then we know that these two triangles are congruent. There's a whole lot of information you know if you know where that perpendicular bisector is located. Again, that's your assignment. Page 306, 3 through 20, 25, 29, 30, 34, 39 through 44.